Section 3.2, number 34. We're given this function, which is a polynomial over a single number. So this 4 divides every one of our terms. And we're asked to determine what the behavior at the right and left ends are. Okay? Now, the right and left behavior has to do with behavior of polynomials. This really isn't written like a polynomial, but we certainly can write it like a polynomial. In fact, the best way to do that is we're dividing by 4 here. Well, that means we have to divide every one of these terms by 4. So 3 divided by 4 we can write as 3/4 x to the 7th minus 2/4 x to the 5th, but 2/4 is the same thing as a half, so I'm going to simplify that a little bit. Plus 5x cubed over 4, well 5/4, well 5 and 4 don't have any common factors, so I'll have to leave that as 5/4 x cubed. And 6x squared, well 6 divided by 4, well they have a 2 in common that I can pull out. So 6 is 3 times 2, so that's a 3, 4 is 2 times 2, so that's a 2x squared. Alright, now, since the question is asking a relatively simple question about the behavior at the endpoints, we know that the behavior at the endpoints is dominated by this leading term, the term with the highest power. So our leading term is this 3/4 x to the 7th. And so way at the right and left endpoints, this is the term that dominates. As x gets really large, well, having 7 of them multiplied together certainly is going to dominate over 5 of them multiplied together, or 3 of them multiplied together, or 2 of them multiplied together. Right? If x is 100, right, this is, well, that's 1 followed by 14 zeros, and this is a 1 followed by 10 zeros. So that's certainly going to be larger. Now, our leading term rule here is that if our coefficient is odd and our if our power is odd and our coefficient is positive, then as x goes to negative infinity, right, as x gets arbitrarily large on the left, our function also goes to negative infinity, right? It gets arbitrarily large negative. When we think about it in terms of evens and odds, right, this would be a negative number multiplied together by itself 7 times. So an odd number of negatives multiplied together is a negative. So if x is negative, our function is negative. And this is a positive out here, so that maintains the sign. So x going to negative means that the function is going to go negative. And then the other part of the rule is on the right, as x goes to positive infinity, our function is going to go to positive infinity, right? It's going to go up positive. So our behavior of our function is going to have to look like it's going to have to look like this. It's going to go up, and it's going to go up. And it does something in the middle that we're not sure about. You know, we would have to graph it to see. But since we're only asked what's happening at the extreme endpoints, maybe we don't care what's going on in the middle. So having that information isn't going to be much use to us. Okay. So as x goes to negative, our function goes to negative infinity, and as x goes to positive, our function goes to positive infinity. Okay? And that's all we need for this one.